Yeah, our today's talk will be pretty much about the Logstash and a complex pipeline one can use to correlate multiple events on the fly before ingesting to Elastic. And honestly saying, we put some kind of effort to kind of simulate certain traffic, and to be honest, and it has nothing to do with actual PhonePe traffic. I just want to put a disclaimer. And so we'll be just discussing about various scenarios and the generic log flow, and eventually what are the challenges if what are the challenges one could observe if they see different logs coming from different log sources carrying the same context, and then eventually how one can fix that. And yeah, these are the regular scenarios. One, like why any org would use ELK stack just on the observability and the logging side, which is visualizing web server metrics and monitoring SSH logins and identifying anomalous password reset attempts in Windows. If you see, as we go along, the use cases may get more complex, which is like monitoring user auth and access events from the identity server and then service provided, etc., etc. Now coming to a generic flow of any, basically the life cycle of a log, right from the log generation till it gets ingested and indexed into Elastic. Primarily, once the log is generated, it is collected by any log shipper, be it beats or syslog or anything, and then followed by sending it to a aggregator. In this case, our aggregator is Logstash, and then followed by ingesting it to Elastic. So few of the collectors are FileBeat, WinLoginBeat or MetricMeat, and the aggregators are Logstash, and the storage and indexing happens in the Elastic. And this is the basic working principle of Logstash, which is which comprises of input, filter, and output. Input is nothing but the way how it receives the event, be it directly from the file input or maybe syslog input, Kafka input, beats input, etc., and then followed by filtering thing where the grokking and slicing and dicing of these log that has been received will happen, and then it will be eventually sent to a different destination. The destination could be Elasticsearch or even a different Logstash server or even a Kafka destination or anything, right? And cool. I'll directly jump on to our example log scenarios. So assume these logs are coming from two different log sources, as in two different boxes. Think about a scenario where a log is generating, matlab, there is an identity provider and then there is a service provider. Matlab, you authenticate with one service and then the actual interaction would happen with a service provider, be it a microservice or anything in that sort. And then if you see, this is a flow of that particular example where multiple users are hitting identity service and service provider, and then we are seeing a challenge here. The challenge is, okay, it's slow. Yeah. The challenge is you can see a user logging from certain IP from certain port, and then in a second log we see the metadata of the user, and then followed by a session that is created for the user, and then followed by what the user has actually done, maybe accessing a resource or something like that, and then followed by a different user doing the same activity, different user is doing the same activity, and then if you observe, we do have the same user logging from a different system. If you observe on the, for example, I am logging in from a desktop, and I am again logging in from another laptop, probably Arch Linux, because Rajnish is fan of Linux. He added Arch Linux here, but so same user logging from different systems, accessing different resources is a chaotic log, right? And then if you see the flow, the first log is user logged in, and it is coming from the identity provider, wherein again user client details and then user session that got created, and if we beautify that, it will look like this. And then there is another log where where it captures what actually user is doing, which is accessing a resource. Probably sometimes user is deleting some service or querying some instance, etc. So now we have two different logs coming from two different log sources with two different things. Now here again the user disconnected from, so previously user logged in, did some activity and then disconnected. This is just a flow. And then coming to the solution.
Yeah, okay.
Yeah, you have to speak like that.
Yeah, so coming to the solution, so how would we solve this particular problem? So like we have these logs, right? So you can see certain information can be extracted out of these logs, and based on the correlation by the username, we finally combine all the multiple events like these three events into just being a single event, and then we use the session ID to be able to extract and get the actual user that has accessed that particular service. So how do we grab all that information and bunch them up all together to frame or create a single event? So let's move on to the solution, like how can we actually do that? So we'll first start analyzing the first log and what important data fields that we can extract out of this log. So we can extract the username, the IP address and the port, right? So how can we extract these fields out of a particular log text through Logstash is the problem or the challenge. So we can do this using the Grok filter plugin. So Logstash comes with the Grok filter plugin where the username, the IP address and the port number can be extracted out just as it is. So
I think this got messed up, this entire.
Yeah, I guess due to the due to the.
But yeah, this is the Grok pattern. You can just refer it.
Yeah. So Grok uses regexes, okay, and this username regex. This username is a Grok pattern which ultimately symbolizes some regex, which should match with this username pattern. The same with the IP Grok pattern, same with the port Grok pattern, which is an integer. So considering all this, we can finally arrive at this Grok pattern, which has this syslog timestamp, the host name, like syslog timestamp. This is the syslog timestamp. This is the host name. This is the IDM service, and the rest of the line along with the username, the IP and the port. So Grok will use all these, this regex, and Grok will extract the relevant information out of that text, and it will put it inside our event map. Similarly, for all other log texts, the rest of the texts, these particular will be the Grok patterns that we'll be using. And so for even for the proxy log and for the disconnection log. So after figuring out all the Grok patterns that we are going to use for extracting all the relevant information out of the log text, and what we want to do next. So we will create a Logstash pipeline. So a typical Logstash pipeline starts just like this, and here we'll just put the Grok filter plugin, and we'll put all our Grok patterns that we have derived. And what it's going to do is, the moment any log comes, it will match with one of these patterns, and it will extract the necessary information out into these particular variables, right, into the event. And so when Grok extracts all those information out, we also need to have conditional statements to detect which particular log line created that particular event and the respective information that was extracted out of it. So after extracting the information, what we need to do? So for example, the first log came. The first log had the username, the IP, and the port, and the second log had these details, and the third log had these details. So we want to bunch them up together to form a single event. So how can we do that in Logstash is a challenge. So again, Logstash has a aggregate filter plugin. So aggregate filter is just a map that's outside the plugin. So sorry, that's outside the pipeline, and the moment some log comes, the thread, the thread comes into action, and the log gets processed in the filter part. And this aggregate map that is out of this particular thread contains all the map or all the information related to all the logs, and it will I mean the logs that come into this filter will be able to insert the data that they have extracted out and aggregate using this aggregate map. So for example, this is the log. This is what we have got out of Grok. So Grok extracted this particular data, and here we have a separate aggregate map with the key of the username, and these details get pushed into this map. Similarly, for the next log line, whenever the next log line comes, so the Grok extract the relevant information, and here we already had the data from the previous log event, which we append with the current log fields that we have extracted out of this particular log line. So these both of these details get aggregated. Similarly, for the last log line, that is the session creation log line, we extract the information, and again it is also appended into this aggregate map. And finally, we have got the whole picture, like we have got the single event that contains all the relevant information of all the all the log lines. So this would be our pipeline, modifications into the pipeline. So we'll use the aggregate plugin, and we'll basically grasp the respective fields that Grok has produced out of the event map, and we'll put it into the aggregate map. And so the same for the same for the next log line, and the same for the session creation log line. And that's how once all the events have ingested all the events have aggregated the respective data fields that we need, we just gonna need to check if each of the values have each of the values have got inserted into the aggregate map. And once that is done, so we can basically pull out the respective values out of the aggregate map and put it inside the event map. And so that's when we can push the final event data that we have got out of the user login, and that's it. So now we want to correlate the sessions. So we have for the first part of the challenge, we have correlated the logs based on the username, and we have created a single event. But now we want to extract the session ID, and using that session ID for each of the activities done by the user, based on the respective session ID, we want to identify the user who has done that. And so we want to correlate the sessions with the activity of the user that we get from the service provider. So how can we do that? Shall we use aggregate? So if we are planning to use aggregate, then obviously we can use the session ID as the key, and we can create an aggregate map, and we can basically get that particular user activity based on this session ID, and put the username as a value inside this aggregate map. And whenever some activity happens, and we can use the session ID to correlate and pull the user name out, and we can put it inside. But this has some limitations, like aggregate stores the data inside within the memory. So we have a limited space. Obviously, aggregate doesn't have a proper method for persistence and long-term storage solution. So suppose we want to store all the sessions that we have got. And for example, a user logs in right now, but the user may continue to be logged in for 1 hour or 2 hours, or maybe even for 24 and 48 hours. So using aggregate in such situations is not a good solution, because at the moment 1,000 and 10,000 users can also log in, and creating aggregate map and putting all the data in the memory isn't a good solution. So we need something else here, and for that we introduce Redis, which is a key value pair based data store that has that can store high volume of data, and it is basically very, very smooth and fast while retrieving the data. So we can call Redis through the Logstash pipeline, and we can insert the session IDs, and we can fetch the username based on the session IDs whenever we want. So for that,
for that, did anyone use Redis in Logstash? Because when we tried using Redis, we realized that it doesn't exist. There is no direct way we can query or make a call to Redis from Logstash. Hence, continue.
Yeah, so Logstash doesn't have a Redis filter plugin. So we can't really use Redis in the filter part of Logstash pipeline. So what can we do next? So, but looking online, we get to know that Redis input plugin exists. So can we make use of the input plugin? But if we want to use the input plugin, then we have to declare it inside the input block, not the filtered block of the pipeline. So what's the solution? So let's dive deeper, and we get to know that Logstash pipeline basically translates into Ruby code, which runs on JRuby, which again gets translated into Java bytecode, which runs on Java virtual machine, and so into the native code which runs on the machine. So what can we really get here? So ultimately, all the Logstash filters and all the pipeline code is actually being executed as a Ruby code. So and we know that Redis input plugin exists, which suggests that Redis Ruby gem also exists on the system within the Logstash within the Logstash instance. So we can make use of this Redis gem. And how can we make use of the Redis gem? So Logstash contains a filter plugin called Ruby, which allows us to put custom Ruby based code and basically do anything we want with Ruby. So what we're gonna do is we will use the Ruby filter, and we'll simply import the Redis gem here, and we'll initialize a new Redis connection in this block, and this global variable RS will help us access this Redis client whenever we want in the entire pipeline at any place. So moving on, we can easily use that as a method to fetch to insert new values into Redis, and to get the values whenever we want out of Redis. And so whenever we don't need any value, we can also delete it. So making changes into the pipeline, we'll initialize the Redis client connection, and we'll go on to get the session ID and the username, and put it as a key value pair whenever the event is whenever the event is about to get triggered. And what we can do next is, whenever we want to get the actual username, we can just get the session ID, which the log of the proxy will have, or the disconnection log will have, and we can get the username and put it inside the event before feeding it for ingestion. And so the same for the disconnection log, and we will finally delete the session out of the Redis. And this is the final picture that we have got. So input source is continuously sending us the logs, and the filter the filter can basically use the aggregate maps for quick data correlation, and the Redis or any other data store for long-term log correlation, and we get this log ingested into the Elastic finally. So concluding, the same method can be used for correlating not just the username but also the host name or source IP, platform ARC, or any other detail, or for any of your solution if you want. And multiple workers can be deployed in a single pipeline. That means that you can have multiple threads that can run for a single pipeline. And so it means that at the same time, it may happen that those 3 logs may come to Logstash at the same time and get processed at the same time. But yeah, we have this if-else condition, if you remember, which checks that until and unless all the values get get inserted into the aggregate map, it's not gonna push the final log into Elastic. So if you remember, this we have used. So again, for long-term correlation, each of the context, like for example in this case, each of the context could be identified using a session ID, and that session ID along with the username or any other details like you want a set of details to store. So you can use Redis or MySQL or anything through the pipeline. You can call it and you can ingest whatever information you want, and you can recall the information through the pipeline whenever you need it. And again, it's not limited to just using Redis. You can use MySQL or SQLite, MongoDB or anything. Just making sure that the respective Ruby filter plugin exists for Logstash for that particular data store. That's it. So if you have any questions, please feel free to bring on.
We assume it is useful. It's just a very pseudocode kind of thing where what anyone else can just use aggregator function and then followed by Ruby code connecting to a data store on the fly. So we have tested this framework. It works at scale, thinking about 10,000 users or more than that logging concurrently in various systems. It can do the correlation and ingest the full log into Elastic, meaning I don't have to do any correlation on the Elasticsearch. Rather, I get the data along with the metadata into Elasticsearch, who he has logged into what server at what time doing what. So that is there in a single log. So anyone can kind of explore this side of things. Thanks.
Yeah, I got a question.
Yeah, please.
How many Logstash instances you are using with this setup?
I may not be able to tell how many instances it can work in a single instance. I mean, single instance, what we tested supports even 10K concurrent requests.
Like when we are using aggregate plugin, right? So it got a restriction. The log needs to be sent into one single Logstash. For example, Krishna, there are 5 different entries.
Correct.
And when we are using multiple Logstash instance,
yeah,
like 3 Logstash instance for three events.
Agreed.
Yeah,
so if the map was created in a different Logstash instance instead of a same instance, probably that time we can use a common shared storage Redis, wherein the map can be stored in Redis itself, and then the lookup can happen from a central place instead of a individual Logstash instance. So even we haven't tested, to be honest. Okay. We only tested with a single instance Logstash. Okay. For us it worked. We didn't need to scale with multiple workers because we had a huge box that can have that can manage large number of log events at any given point in time. But yeah, I think maybe with multiple, I thought to put that as a disclaimer, but yeah, with multiple instances, maybe there needs more tweak outs with that Redis and other things.
Okay. Yeah. Yeah, the file bit is reading a log. It got 10 different entries, and you have 3 Logstash instances. So those 10 different entries
probably
need not to go to one single instance, right?
Persist it to send it to a single instance.
Yeah, like when it gets sent to in a round robin fashion, so any of the Logstash will get, consider like 100, same user, 100 lines are printed. So 3 Logstash instances running parallelly, so each will get 35, 40. So in that case, the aggregate plugin will not make more sense because Logstash cannot be, it cannot communicate with other Logstash. So that's event
correct.
Will be partial.
That's correct, but you can actually segregate all the loads of logs that are coming to Logstash, not using I assume that your question is coming from using a load balancer before multiple log stashes, and you don't know that which particular log source is actually
Yes.
sending to which log stash, right?
Yes.
So remove the load balancer and do the balancing on the client side. Yeah.
How will you do it? Like,
Yeah, so on the client, on the log source side itself, you can define which log stash it should actually send the data to.
I mean, there are
Yeah.
many hacky ways. You know,
Yeah.
you can use you can use any, let's say, layer 4 load balancer that can do a TCP persistent session and then
How
send it
about,
to a single destination.
how about sending, I faced a similar situation, send all data to one Logstash, use the grok, segregate the data, send the destination data to Redis. From Redis, you get the all processed data and aggregate in next level of Logstash. Two different Logstash
No,
in between
the
Redis.
context is, in our case,
Okay.
a user logs in the morning, okay, may do many things and logs out in the evening. Now I have to persist entire journey of the user in a single instance, so that I have the correlation already sorted in the map, so I'll retrieve it throughout his journey. And then that is what is getting ingested in Elastic, right?
Okay.
Again, even for the assumption with a load balancer, what you can do is there are several load balancers that come up with, that come with feature that has map-based load redirection, where you can have a particular subnet defined that for this particular subnet, the traffic should go to this particular log stash, and based on that you can segregate and you can solve this. I mean,
simple answer is Nginx will work.
Nginx works, yeah, of course. Yeah.
Yeah. So I'm just curious if we have explored vector in place of the Logstash and the vector aggregator. for this.
No, we explored vector, we explored Fluentd, we explored Logstash. To be honest, we are using all of them since this call is on Elastic Conference.
Again, so even we also use vector and vector aggregator, and then all the logs we are ingesting into Elasticsearch only. So I'm talking in place of the Logstash and aggregator, and then again it goes to the Elasticsearch. So this also solves. So vector agent will run on all the nodes in wherever the logs are generating, and then you can see.
So no,
Vector
I
also-
think we are using predominantly Logstash as an aggregator. The reason being is it's not that we use beats or any standard Elastic log collectors. We use syslog actually, because that exists in every damn server, and then we can source from syslog to Logstash very seamlessly. Even we can do it in vector also. But the point is, since we are using beats at places and then non-beats, so since we are also using beats at some places and then we are using syslog, so it makes sense for us to use Logstash, and then instead of vector we use fluent beat at places where it makes sense. But Logstash is predominantly for the aggregation, because we need to stick to one solution at the end of the day. So that's how we realize this works.
Thank you.
And then the Ruby code base is not supported in vector or any, so it doesn't support any generic code. It can only support whatever is there in the documentation, wherein this allows us to tweak many other, way more things, not just the Redis thing. We can even do the computation on the fly and then ingest to Elastic.
yeah, that's a really good advantage of Logstash.